For 100,000 years, humans have looked up at the night sky and wondered about those awesome points of light. What are they? What are they made of? How did they get there? They didn't have the technology to find out, so they guessed that magical beings had created it all. If you prefer making wild guesses instead of using observation, measurement and calculation, then here's a sealed box. Spend the next 10 minutes guessing what's inside and come back again at the end of this video. Because this video doesn't cover what we guess about the universe, but what we know, and more importantly, how we know it. How do we know where the stars and galaxies came from, and how old they are? The first person to take a stab at gauging the scale of the world around him was the Greek scientist Eratosthenes of Cyrene. He knew that on the longest day of the year the sun was directly overhead at Syene in the south of Egypt, but cast a shadow in Alexandria to the north. By measuring the length of the shadow, he could work out the Earth's diameter. But while the Earth might be spherical, the dogma of a fixed Earth still held sway, backed by a powerful church. Problem was, this didn't fit the observable evidence, especially the observation that some wandering stars, or planets in Greek, had very erratic orbits around the Earth. When the telescope was invented, these planets turned out to be very different to the fixed stars. But it wasn't until Johannes Kepler calculated the exact orbits of the planets that a model of the solar system at last fit the observations. His law of planetary motion turned this into this. In the 18th century, a transit of Venus across the Sun, timed at opposite ends of the Earth, made it possible to calculate the exact distance of the Sun, and by extension the distances of all the known planets. But that still left the stars. The easiest way to measure their distance is a system called triangulation, which is used to measure distant objects on Earth. With stars, the baseline is the Earth's orbit around the Sun. Take an angle measurement here, and 6 months later here, and just do the math. This principle was known in the 17th century, that their instruments simply weren't accurate enough to measure such a tiny angle. But in 1838 the technology had caught up. The Prussian astronomer Bessel found that the binary star 61 Cygni was an astounding 60 trillion miles away. It was a distance so huge that it had to be measured in terms of the number of years it took light to cross it, 10.3 light years. Our universe just got bigger. Triangulation only works for stars up to 100 light-years away, but it was a start. Knowing the distances of these stars, astronomers could work out the relationship between a star's distance and its brightness, because closer stars are generally brighter than distant ones. Using this calculation, they could now estimate the distance of the faintest stars they could see. It was only an estimate, but our universe got bigger again. We seemed to be on the edge of a huge wheel of stars in space. While the brightness of a star gives us an estimate of its distance, confirmation comes in another trick of triangulation. In 1987, a star was seen to explode inside our galaxy. The exploding star is called a supernova, and it's very bright. As it happened, this particular supernova was surrounded by a huge gas cloud far out into space. The light from the exploding supernova raced across the gap, and 8 months later it hit the surrounding gas cloud. Cosmologists saw the reflected glow. We know the speed of light, so we know how far it can travel in 8 months. And that means we know the distance between the supernova and the gas cloud. All cosmologists had to do is measure the angle between the two as seen from Earth, and once again it's simple triangulation. We can work out the distance of the supernova, 169,000 light-years. That means we're looking at an event that happened 169,000 years ago. Our universe was now huge. By simply observing and measuring, we'd calculated a scale in time and space that was far greater than Bronze Age people ever imagined. But one question still confounded scientists. What are all these stars made of? To understand the evidence, we have to understand the atom. There are around 92 different types of atom, known as elements. They differ in the number of electrons, protons, and neutrons they have. When an atom emits light, it absorbs the light of particular wavelengths. Each element absorbs a different set of wavelengths. We can see these absorption patterns as lines when we look through an instrument called a spectroscope. This one shows the spectral lines of three elements that were very familiar to early 19th century scientists: hydrogen, lithium, and oxygen. But when the French astronomer Pierre Janssen pointed a spectroscope at the Sun in 1868, he found a set of spectral lines no one had ever seen before. It was a completely unknown element. He called it helium, after the Greek word helios, the sun. The new element also showed up in stars, along with another abundant element, hydrogen. Inside this tightly bound universe, which they called the galaxy, astronomers could see strange swirling clouds through their telescopes. Some astronomers thought these could be other galaxies just like our own. In 1917, a supernova was seen to explode inside a cloud called Andromeda. Supernovae are usually very bright, but this one was quite faint. Using the brightness and distance calculation, cosmologists work out just how far away Andromeda was: 2 million light-years. That put it well outside our own galaxy, and triangulation showed just how big it was, about the size of our own galaxy. The universe, it turned out, extended well beyond our own cluster of stars, and millions of years back in time. American astronomer Edwin Hubble soon discovered that other galaxies were even further away. He also confirmed an observation that they were all moving away from us at incredible speed. Those furthest away were going the fastest. In other words, our universe was expanding, as if we were caught up in a huge explosion. How do we know this? I'll explain with a more prosaic example. When you watch a car speed past, sounding its horn, the pitch seems to change. As it's coming towards you, the sound waves are bunched up, so the horn seems to have a high pitch. As it passes by, the pitch suddenly drops, because now the sound waves are being stretched out. This is called the Doppler effect. Just by measuring the change in pitch, an observer can calculate the speed of the car, and whether it's coming towards him or moving away. We can do the same with stars and galaxies, using light instead of sound. If a galaxy is moving away, the spectral lines will shift towards the red end of the spectrum. The opposite happens if a galaxy is coming closer. They move towards the blue end. So cosmologists could not only calculate which direction the galaxies are moving, but also their speed. But what happens if we wind the film back, as it were? What happens is that all these moving galaxies lead back to the same point in space and time, this point, around 14 billion years ago. The explosion of all this matter is called the Big Bang, and that's as far as we've got so far in our understanding of the scale and time span of the universe. Research is now continuing to discover what happened before the Big Bang. Now let's come back to that sealed box. To the people who decided to skip the video in order to speculate on the contents, have you figured out what's inside yet? Of course not. Sitting in an armchair and making wild guesses tells you nothing. You're really no better off than the Bronze Age farmers who looked up at the stars and tried to guess what they were. Just because the Big Bang is the current extent of our knowledge doesn't mean we've reached the end of the story. Every time in history people thought they knew the scale of the universe, they've always been proved wrong. To me, the real story of the universe is way more interesting than myths and fairy tales. For 100,000 years, humans have stared up at the same night sky and wondered. We are the first people in human history not to wonder, not to guess, but to know.